Hey guys, it's Miss Casano, and today we're going to go over some of the review questions from the Quarterly 1 review sheet. So you can skip ahead to any question that you want to see me go over. So yeah, let's get started. So question 1 and 2 are talking about something we learned very early on in the school year, and that's the definition of a function. The definition of a function is for each unique input, there is some output. So for each unique x value, it has some y value. Now, when we're trying to determine if a relation is a function, we need to see that every single x value goes to some y value. It doesn't matter if two different x values go to the same y value. That's fine. However, if the same x value gets mapped to two different y values, then that's a problem, and that would make it not a function. So let's look at number 1. In choice A, we have 0 being mapped to 3, so I have an x value of 0 getting mapped to a y value of 3, and an x value of 0 getting mapped to a y value of 5. So since my unique x is getting mapped to two different things, that can't be a function. Same thing on choice B. 6 is getting mapped to both 0 and 2, so that's not a function. And same thing in D. 0 is getting mapped to both 5 and 6, and 1 is getting mapped to both 4 and 5. Let's look at C. 8's getting mapped to 2, 9's getting mapped to 2, and 10's getting mapped to 2. Now, if 8 was getting mapped to, let's say, 2 and 1, that would make it not a function. But since each unique x value has some y value, that makes it a function, and this ordered pair represents a function. So it's a little different now. 1-to-1 is a step further. So first you classify something as a function, and then you can say if it's 1-to-1 or not. And the thing that's different about 1-to-1 is that each x value has to have a unique y value. There's no sharing. So if I have a 0, it has to go to a 3. It can't go to anything else. So let's see. I have 0 that goes to 1. That's fine. I have 1 that goes to 2, 2 that goes to 3, 3 that goes to 4. That's fine. That's 1-to-1, so I'm going to cross it out. Here I have 0 going to 0, 1 to going 1, 2 to going to 2, 3 to going to 3. There's no repeating in x values or no repeating in y values. So that's 1-to-1. Here I have 0 going to 1, 1 going to 0, 2 going to 3, 3 going to 2. That's 1-to-1, so I'm going to cross that out, and let's look at D. I have 0 going to 1, 1 going to 0, 2 going to 0. Here's our problem. 1 and 2 are both unique x values, but they're being mapped to the same y value. They're sharing a y value, so that would make it not 1-to-1. If g of x equals negative 4x squared minus 3x plus 2, determine g of negative 2. So this is a basic substitution question where we have g of negative 2 is basically saying wherever you've seen x, you're just going to put in a negative 2. So you're going to substitute in. G of negative 2 equals negative 4 times negative 2 squared minus 3 times negative 2 plus 2. So after we substitute and evaluate our expression, we get that g of negative 2 is negative 8. If the domain of f of x equals 2x plus 1 is negative 2 less than or equal to x less than or equal to 3, which integer is not in the range? So if they're giving you a domain, they're giving you a set of x values. And basically they're asking which one of these integers of these 4 choices is not in the range. And we know that a range is y values. So in order to figure out which one of these is not in the range, f of x is the same thing as saying y. And that's something we learned the first day of school. So we can rewrite this equation by saying y equals 2x plus 1. And basically the way that I want you to approach these kind of questions is set your equation, so 2x plus 1, equal to each of these y values. And what's going to happen is you're going to solve for x, and you're going to end up with one x value that does not fall inside this set. So I set my equation equal to my first y value, which is negative 4, and I solve for x. And basically I'm just trying to see what x value will make my function negative 4, and I want to see if that x value falls inside my domain. Now, negative 5 over 2, simplify, I put it in decimal form, it's negative 2.5. And if we go back up to our original domain stops at negative 2. And negative 2.5 would fall outside of our domain set. So we know that if negative 2.5 is not in our domain, negative 4 can't be in our range. So given f of x equals 1/2 x plus 8, which equation represents the inverse? So whenever you see inverse, you should always think switch the locations of my x and my y's. F of x is the same thing as saying y, and that's something we learned at the very beginning of the year. So I'm just going to substitute in y for f of x. And then all you're going to do is switch the locations of your x and your y. So wherever my y is, that's where I'm going to put my x, and wherever my x is, that's where I'm going to put my y. So my equation turns into x equals 1/2 y plus 8. And then all you're going to do is solve this equation for y. So I'm going to subtract 8 from both sides, get x minus 8 equals 1/2 y. I want to get y by itself, so in order to get rid of that 1/2, I'm going to multiply by its reciprocal, which is 2 over 1, because that will make the fraction turn into 1. And then I'm going to multiply by 2 over 1 on the other side. Be very careful. Don't forget to distribute. You're not just multiplying this 2 by the x, you're multiplying it by x and the negative 8. So after you distribute the 2 to the x and the 2 to the negative 8, you are left with 2x minus 16 equals y, and that is it. You just solve for your inverse. A more technical way to write this is f of negative 1 of x. This is inverse notation. It might come up on a multiple choice question. So that's pretty much it. So when we are determining if a function is even, odd, or neither, we're going to substitute in a negative x. So everywhere we see an x, we're going to substitute in a negative x. And we're going to observe what happens to the signs. And I just wrote out a little cheat sheet. If the signs stay the same or it's equal to the original function, the function's even. If the signs are all opposite than the original function, the function's odd. And if the signs are some weird mix of equal and opposite, so some stay the same, some change, then the function is neither. So I'm going to plug in a negative x to this function and observe what happens to my signs. So 5 times negative x cubed plus 10 times negative x. Negative x cubed comes out just as negative x cubed. So I'm just going to put the negative at the front. So negative 5x cubed plus 10 times negative x. So that just turns into negative 10x. So the sign of 5x cubed is negative here, but the original sign is positive, so they're opposite. The sign of 10x here is negative. The original is positive, so that makes it opposite. All signs are opposite, so f of x is an odd function. And the reason is because when you plug in a negative x, you get the negative or opposite, that's what that little minus sign means, function f of x. So whenever you see average rate of change, you should be thinking slope. So the average rate of change formula is f of b minus f of a, and this is just a change in y value. B minus a, this is just a change in x value. So it's just slope formula, just written in a different way. And they're giving you some interval. This interval is x values. So our interval is negative 5 to negative 4. So negative 5 is my a, negative 4 is my b. So I'm just going to plug into my formula. F of b, well, b is negative 4, minus f of a, which is just negative 5, over negative 4 minus negative 5. Now, the way that we figure out f of negative 4 and f of negative 5 is we just substitute those values into our original equation. So f of negative 4 equals negative 4 squared minus 7 times negative 4, and f of negative 5 is negative 5 squared minus 7 times negative 5. And then you're going to evaluate that. So when you evaluate f of negative 4, you get 44, and when you evaluate f of negative 5, you get 60. And then you're just going to come back to your average rate of change formula and plug in. F of negative 4 is 44. F of negative 5 is 60, so 44 minus 60 over b is negative 4 minus a negative 5. 44 minus 60 is negative 16 over 4 minus a negative 5 turns into negative 4 plus 5, which is 1. So our average rate of change is negative 16. Transformation of y equals f of x moves the graph 5 units to the right and 4 units down. So when we're moving left to right, we're moving on the x-axis. So we're going to place this number inside our function. When we're moving up to down or down to up, we're moving on our y-axis. So that number goes outside our function. So our parent function is y equals f of x. Now, after our transformation of 5 units to the right, well, we have to remember what's our positive direction and what's our negative direction. And when we're doing transformation of functions, sadly, it's a little counterintuitive. When we're moving to the right, it's negative. When we're moving to the left, it's positive. But up and down stay the same. Up is positive, down is negative. So, y equals f of x. If I'm moving to the right 5 units, I'm moving on my x-axis, so this number is going to go inside. So minus 5. And then I'm moving down 4. So that number is going to go on the outside, minus 4. And that's it. So when we're factoring, we are always first looking to see if there's any GCF we can pull out. And looking at this, I don't see a GCF. I don't see any numbers or variables that all of these terms share. So the next step is to count how many terms you have. So this is a trinomial because we have 1, 2, 3 terms. So we're going to use our AC method to factor. I'm going to take my first term and multiply it by my last term. And when I do that, I get 100 x squared y squared. So then we want to find two numbers that multiply to 100 and add to negative 20. So the two numbers that add to negative 20xy is negative 10xy plus negative 10xy, and that multiplies to positive 100x squared y squared. So we found our magic number, and now we're just going to substitute it. So 25x squared. Now instead of writing negative 20xy, I'm going to write negative 10xy, negative 10xy plus 4y squared. Split it down the middle, and we are going to look for any common factors to pull out. In my first group of terms, I could pull out a 5 and an x, and that would leave me with 5x minus 2y. And in my second term, I want to get this parenthesis to be over here. So I can pull out a 2y, a negative 2y, and that will leave me with 5x minus 2y. Since these two parentheses match, we know we did it right. So our factors are 5x minus 2y times 5x minus 2y. Our factoring, we always start to look for a GCF. Looking at this, again, I don't see any GCF that we can pull out. I don't see any numbers or variables that every single term shares. So then we go to counting how many terms we have. This has 1, 2, 3, 4, and our method for factoring a polynomial with 4 terms is you split it right down the middle. So you pull out, and then you look to see if you can factor the first group and then factor the second group. So in the first group, I can pull out an x squared, and that would leave me with x minus 1. And the second group, they both have a 2, so I can pull out a GCF of 2. and I'd be left with x minus 1. Since both these parentheses match, you know you did it right. And then you're going to combine your terms. So x squared plus 2 times x minus 1. Now this is done. It's in fully factored form. So we're given x cubed plus 64 to factor completely. Again, I always start to look for my GCF. I don't see one here, so I can't pull anything out. The next thing you do is count the amount of terms you have. This is a binomial. It has 2 terms, and our method for factoring binomials is dots, and that means difference of 2 squares. X cubed is not a perfect square, and there's no difference, so we can't use dots. The only other option we have is the sum and difference of perfect cubes. X cubed is a perfect cube, and so is 64, so it looks like we are going to be using that. So your first step is to uncube your cube. So I'm going to take the cubed root of x cubed, and that is x, and that equals a. And then I'm going to take the cubed root of 64, that is 4, and that equals b. And then I'm just going to write out a squared, ab, b squared. And I left the signs out on purpose because the way that we figure out our signs is SOAP. And that means same as the original, opposite as the original, always positive. And then you're just going to substitute in. A is x, b is 4, a squared is just x squared, a times b is just 4x, and 4 squared is 16. These solutions to the equation 8x squared minus 28x equals 16. I really don't see a way to do this other than moving over the 16 and making it 8x squared minus 28x minus 16 equals 0 and factoring it. So let's do it that way. Our first line of defense when we're factoring is always to pull out a GCF. And here I see a GCF of 4. So that means each of these terms have factors of 4. So when I pull out a GCF, I'm just dividing each term by it. So 8x squared divided by 4 is 2x squared. Negative 28x divided by 4 is 7x. Negative 16 divided by 4 is minus 4 equals 0. So we pulled out our GCF, and our next step is to count the number of terms. This polynomial has 3 terms, so we're going to use our AC method. Take our first number and multiply it by our last number, which is negative 8x squared. And then we are going to find 2 numbers that add to negative 7x and multiply to negative 8x squared. So I found that the 2 numbers that add to negative 7x is negative 8x plus 1x, and the 2 numbers that multiply to negative 8x squared is negative 8x times 1x. So then I'm going to substitute this into my equation. So 4 times 2x squared minus 8x plus x minus 4 equals 0. Split it down the middle. I'm going to look to pull a GCF from both groups. So here's my first group. I can pull out a 2 and an x. So 2x, that leaves me with x minus 4. And I want the parentheses to match, so I'm just going to pull out a 1 over here because I already have the x minus 4. So, smushed everything together, 4 times 2x plus 1 times x minus 4 all equals 0. So then we just set each thing equal to 0. 4 equals 0, 2x plus 1 equals 0, x minus 4 equals 0. And then we just solve each little mini equation for x, and those are the answers to our equation. So 4 equals 0 doesn't really mean much. It doesn't make any sense, so we reject it. I solve 2x plus 1 equals 0 for x, and I get x equals negative 1/2. So that's one answer to our equation. And then I solve x minus 4 for equals 0 for x, and I get x equals 4. So the solutions to our equation are negative 1/2 and 4. Question is in simplest form. So basically, all we have to do is go through each answer and see if we can simplify it any further. X over x squared, I'm going to rewrite it as x over x times x, and we know that if we have matching things on the top and the bottom, we can just cross them out, and that leaves us with 1 over x. So x over x squared can be simplified more, so that is obviously not in simplest form. X squared minus 9 can be factored. It's difference of two perfect squares, so it'll be x plus 3, x minus 3 over x plus 3. I have an x plus 3 on the top and an x plus 3 on the bottom, so that leaves me with x minus 3. Obviously, that can be simplified more, so that's not in simplest form. X squared minus 6x plus 9. That can be broken up into x minus 3 times x minus 3, and x squared minus x minus 6 can be broken up into... And when you factor x squared minus x minus 6, you get x minus 3, x plus 2. You have an x minus 3 in the top and x minus 3 in the bottom, so you're left with x minus 3 over x plus 2. Obviously, that was not fully simplified, so you can cross that out. Let's look at option B. Obviously, that's the answer because it's the only one remaining, but let's look at why. We have 4, that's just a number, over x squared plus 4. There's nothing we can do that's binomial. X squared and 4 are perfect squares. However, there's no difference, so you can't break that up anymore. So the answer is B. So another odd, even, or neither question. What we're going to do is plug in a negative x and observe how the signs change. If all the signs stay the same after we plug in a negative x, we can say that they're equal to the original function, then it's even. If all the signs are opposite, it's odd, and if you get some weird mix of opposite and equal, or same or different, then it's neither. So let's plug in a negative x. So negative x cubed plus negative x squared plus negative x plus 1. Negative x cubed is just negative x cubed. Negative x squared is positive x squared minus x plus 1. My original sign for x cubed was positive, and now it's negative, so it's opposite. My original sign for x squared was positive, and now it's the same. So you can stop right here. You have a mix of opposite and same, so we can say that it's neither. For it to be odd, they all have to be opposite, and for it to be even, they all have to be the same. Now it says state your answer with mathematical reasoning, and this is the mathematical way of saying it, neither, because f of negative x, so when you plug in a negative x, if it's even, you're going to get the original function back, or all the signs the same. Well, it's neither because that didn't happen. And then, if you plug in a negative x, and it's odd, you're going to get the opposite function, or the negative function. And it's neither because that didn't happen either. On the test, if you forget how to write these little mathematical statements, it's fine, but you do have to support your answer with some kind of reasoning. Tell me because some of the signs changed and some of the signs didn't. That's fine. You just have to show me what you're thinking. So this is a rational equation. State the answers as a set and check for extraneous roots. So my first step here is to factor first. So x squared minus 5x minus 6 equals 0. It's my AC method, so take my first term, multiply by my last term. So I need to find two numbers that add to negative 5x and multiply to negative 6x squared. So the number that adds to negative 5x and multiplies to negative 6x squared is negative 6x times x. So I'm going to substitute in x squared minus 6x plus x minus 6 equals 0. Split it down the middle and pull out a GCF, which is x minus 6, and this is 1, x minus 6. So this factored is x plus 1, x minus 6. So looking at this, our LCD is going to be x plus 1 times x minus 6. So what we are going to do is build up each fraction to have this LCD because we want to be able to throw out our denominators. So 4 over x plus 1, let's look at what the bottom's missing. The bottom's missing x minus 6, so I'm going to multiply the top and the bottom by x minus 6. Plus 1 over x plus 1 times x minus 6 isn't missing anything, so we don't need to multiply by anything. It already has our LCD. Equals x minus 6, well, that's missing our x plus 1. So we multiply the top and the bottom by x plus 1. So we have 4 times x minus 6 over x plus 1 times x minus 6 plus 1 over x plus 1 x minus 6 equals x plus 1 over x plus 1 x minus 6. They all have the same denominators, so we can throw them out and then solve our equation. So all I did was distribute my 4 to my x to my x distributed my 4 to my x and to my negative 6, and I rewrote it without the denominators. And now we're just going to solve this like a regular linear equation. So I'm going to combine like terms. 4x minus 24 plus 1 is minus 23 equals x plus 1. I'm going to move x over, so I'm going to subtract both sides by x. So that leaves me with 3x minus 23 equals 1, and I'm going to add 23 to both sides. So I get 3x equals 24. Divide both sides by 3, and I get x equals 8. Now, before we can say x equals 8 is our answer, we have to go back up to our original question and check the denominators. Does 8 make any of the denominators 0? And looking at it, it does not. So that means 8 is a solution, and we write it as a set. So we just put the brackets around it. And that's it. Solve the following systems of equations. So we're given 3 equations with 3 unknowns, and our first goal is to get these 3 equations with 3 unknowns or 3 variables down to 2 equations with 2 variables. And the way that we're going to do it is we're going to pair them up. So I'm going to do my first and my middle, and then I'm going to do my middle and my last. It doesn't matter which you pair up with which, as long as you're using all your equations. And we're going to pair them up and use the elimination method to eliminate one variable. So looking at your equations, before you jump into it, you should observe what coefficients you have in front of each variable. So in front of my y, I have a negative 2y and a positive 2y. I'm actually going to do my top and my bottom one. So if I combine those right off the bat, my y's would cancel. So I'm going to choose to cancel y first. It doesn't matter what variable you pick to cancel first. As long as you're not making any silly mistakes in your algebra, you're going to get to the right answer. But there are smarter ways to go about these kind of questions. And it's just based off of looking at the coefficients in front of your variables. I have 2 2's and a y, so it's just going to be easier to manipulate those to cancel. So what you're going to do is you're going to write out the top one. So x minus 2y plus 3z equals 7, and 2x plus y plus c equals 4. Now I want to get my y to cancel, so I have a negative 2y up here. I want this to be a positive 2y. So I'm going to multiply the bottom equation by 2. So you're left with x minus 2y plus 3z equals 7. 2 times 2x is 4x. 2 times y is 2y, 2 times z is 2z, 4 times 2 is 8. And then you're just going to combine. Your y's canceled just like you wanted. X plus 4x is 5x, 3z plus 2z is 5z, and 7 plus 8 is 15. That's our first equation with 2 variables and 2 unknowns. Now I'm going to take my top equation, which was x minus 2y plus 3z equals 7, and my bottom equation, which is negative 3x plus 2y minus 2z equals negative 10. I have a negative, since I canceled out a y in the first one, I have to cancel out y in the second one. So I have a negative 2y in the first one and a positive 2y in the second one. So those cancel, we don't have to do any multiplying, so that's good. And then we just combine. X minus 3x is negative 2x, 3 minus 2z is positive z equals negative 3. And this is my second equation. So we got our system of 3 equations with 3 variables down to a system of 2 equations with 2 variables. So I'm just going to rewrite these systems. So now I want to use elimination again to cancel out another variable, and then ultimately I'm going to have one variable and then I can solve for it. So I'm going to multiply this bottom equation by negative 5. So negative 5 times negative, I'm just going to rewrite the top one, 5x plus 5z equals 15. Negative 5 times 2x is negative 10x. Negative 5 times z is negative 5z equals negative 5 times negative 3 is 15. And then I'm just going to combine my like terms. So 5z and negative 5z cancel out, and I'm left with 5x plus negative 10x, and that leaves you with negative 5x equals 30. I actually made a mistake, silly mistake. Negative 5 times negative 2 is positive 10, so then 5x plus 10x is 15x equals 30. So be careful with your negatives. I'm going to divide both sides by 15, and I get x equals 2. Now I have x, I can work backwards. So I got all the way down to one variable, and now I'm going to take that one variable and work up. So I'm going to start with my 2 equations with 2 unknowns. I'm going to plug it into negative 2x plus c equals negative 3. You can plug it into either one, doesn't matter. So I'm just going to substitute x in, and now we're going to be able to get z now. 2 plus z equals negative 3. Negative 2 times 2 is negative 4, plus c equals negative 3. Add 4 to both sides, and you get z equals 1. So we have x, we have z, and now we're going to move up one more level, right back up to the system of 3 equations with 3 unknowns, and I'm going to substitute in to those to get my y value. So all I did was just substitute in x, which is 2, and then z, which is 1. So then you get 2 minus 2y plus 3 equals 7. 2 combined with 3 gives you 5 minus 2y equals 7. Subtract 5, subtract 5, and you get negative 2y equals 2. Divide both sides, and you get y equals negative 1. So it's not enough just to leave it with all them boxed in like that. You have to display it as a point, because when you're solving a system of equations, you're really solving for the point of intersection of all these lines. So we write it just like we write an xy point, except now we have a z. So it'd be x, y, z. So my x was 2, my y was negative 1, and my z was 1. And that is your answer.